Hello, this is a demo of the VisKonz Testsuite. At the moment, there are three possibilities to test applications depending on the domain of the to-be-tested software. The first possibility is the table test, which resembles the Fitnesse-Framework in that it uses tables to formulate tests. Our table tests enable acceptance tests for Java and diverse Smalltalk dialects. One difference to the Fitnesse-Framework is that no modification to Java source code is necessary. In fact, it need not be available. In the Smalltalk edition, the table cells as well as the table headers can contain any Smalltalk syntax, making this feature very powerful. In general, table tests make testing of any Java or Smalltalk application possible. The table tests are most comfortably created and edited in our Seaside application. This is a list of sample test tables that can be shown and hidden using the appropriate buttons. First, let's take a look at the Java sample test, wages, which is adopted from the Fit framework. The software to be tested is accounting software in Java, which is supposed to calculate the total wage of an employee considering standard hours, holiday hours, over hours, and his wage. Each row in this table is a certain test case, values for input and values for expected output. The column headers can contain variable names or method names, the latter of which can be distinguished by parentheses. All columns, except for the last one, set values. The last column queries a value. Our Java backend, Testsuite.java, has to run in the background to enable testing of any Java application. Next, we can perform the tests and collect the results. The last column entries show the expected values. If the last column is blue, the test passed. If it is red, the test failed, and the alternating value is shown. Now let us test Smalltalk applications. First, an example that tests the Squeak morphic user interface. In the test definition, we type 9008 because that's the port on which we run the Squeak image. Then submit the tests. In the background, we can see morphs being tested. For this tutorial, delays have been employed, otherwise the morphs would not show. An even simpler example creates a morph, changes its location, then evaluates Explore to open an Object Explorer on the morph. Now we take a look at an example to test Seaside applications. Since any Smalltalk syntax can be used in column names, we can query how many Seaside components are active in the system. In the second row, the value is higher than 1 because each row is a Seaside component itself, and the Smalltalk image we test is the same that renders the test tables. We can open any number of Smalltalk images, for example, a Dolphin image, which expects test queries on port 9009. This trivial test table creates a new dictionary, opens a Flipper Explorer for it, and tests if it is empty. These were only a few simple examples, but tests of any complexity can be formulated by using complex expressions in the column names or table cells. The second possibility the test suite offers is specialized on testing running Seaside applications. The halo tests extend the common Seaside halos by a test button and enable us to look into Seaside components at runtime comfortably. These tests also can use any Smalltalk expression and are defined separately in a list so that different components can be selected for testing. We begin by starting a Dolphin image and start the Query Vision Seaside server on port 8800. When we use a web browser to visit localhost :8800, we see the Seaside startup screen. We visit a standard Seaside example. If we click on Toggle Halos, the Seaside halos are shown. These were extended by the Halo Test feature. Before we can apply a test, we have to take a look at how these are defined. For this, we use the entry Define Halo Test. A list of all the defined tests is displayed, including their code. Above, we see examples that serve only as utilities. Below, we see functional tests. At first, let us try the first entry of the list, another trivial example. In the Seaside application, we test the second counter component by clicking on Set Test in its halo. A list opens in which we can select the name of the test. The test was performed and the result was a date string. Clicking on Update repeats the test. We return to the component to select a different test. The utility entry, Inspect Test, opens the Seaside component to inspect it in the image. A flipper inspector is opened, with which we could take apart the object. This time, we select Browse Class of the Object. A class browser is opened, with which you get messages your test objects can understand. Using that information, you can define your own tests.